Okay, so what I'm thinking for today is to quickly give you starters for the homework on public goods, which is short and sweet this time, completely unlike the general equilibrium one, which was long and sweet. Well, your taste may vary, yes. Understood. For that, as an answer key, I have just in fact actually scanned or photographed one student's particularly comprehensive answer. And when I'm back in the office, I want to kind of put the pictures together and post them. So many thanks to Sudon for allowing me to do that. While I'm talking about that, for some of the problems, the answers may appear different even though you did it correctly. For example, you chose to add prices and set them equal to 1.
Yeah.
He chose to set P1 equal to 1. So the answers for the transfer thing may look different, but they're not really.
Okay.
Because,
Yeah.
of course, the normalization will make a difference because the normalization of prices affects what is a dollar in that economy.
Okay.
So,
I actually have a question.
so yeah, you do. Okay. So actually, why not start with questions, and then we'll So questions on general equilibrium, questions on public goods. I know that I went really fast over Thomson, so if you have questions about that, that's also fine. And then we'll talk a little bit about the homework.
Right.
So your question.
Okay, so I have 3 questions overall, but honestly,
Okay.
it doesn't. First one, I guess we can talk about since you're already talking about normalization of prices. I'm just a little confused at what effect that has on it. I understand putting them into relative prices, but
Right.
I don't know if I think there's a disconnect for me as to what that actually entails and what that implies about the problem that we're doing.
Okay. In a general equilibrium system, the price vector is fundamentally indeterminate. The main reason for this is that the excess demand function for everybody in the economy is homogeneous of degree 0. So you can scale up the prices, all prices, by the same positive factor. It's going to make not a whit of difference to the excess demands, right? Mm-hmm. So you have one degree of freedom, one floating choice free for you to make. Where are you going to fix the unit by which you measure prices?
Okay.
Right? Mm-hmm. And there are 3 normalizations that are commonly employed in general equilibrium. One is if you have a commodity that you know in all reasonable allocations, all reasonable efficient allocations will end up corresponding to an equilibrium where that good has a positive price. If you know that, then you could set that price to be 1. In all of our problems, we had no problem of that sort, so you could normalize with 1. You don't want to do that. It wouldn't make sense if at the equilibrium, or one of the equilibria in case there are more than 1, if the price of that good might end up being 0, then you really are messing up by changing the 0 to the 1, right?
Yeah.
So that's the story of the numeraire. You can normalize by choosing a good whose price is going to end up positive and set that price 1.
Okay.
For existence proofs, people do things like this. When you expect to be using a compact convex set for a fixed point argument, and the set includes partly the prices, then you normalize them by P1 plus P2 equals 1, because now this is now a compact convex set. If you had P1 equal to 1, and even if you, as I did here, restrict to non-negative prices, then you would not have a compact set because P2 would be going and going and going. All right? So that is one popular choice for existence proofs. Not that I'll ask you to do an existence proof, but you will see it the more you read. Another one is for papers, and that really is obscure and you're not going to see it most likely, but papers in which you look for general equilibrium where goods can be goods or bads, and so you have no guarantee that the prices are going to turn up positive, then people sometimes normalize by putting it in the circle. And then constructing some elaborate fixed point argument to prove the existence. And to be very, very honest, the last time I remember looking at such a thing was academic year 1985-86. And I've forgotten now what paper and what. But I remember that has been used by some. And you can use it, of course, instead of, oh, actually, yeah, Arrow and Han, assuming non-negative prices, use that part, I believe, and they mapped every point of it this way to the simplex, which is compact convex. So that, those are the three standard, let's call them, normalizations of prices.
Okay.
You will hardly ever need this, not in this class. But the caution is, if you're going to make a good enumerator, it better have a positive price. And we had some examples where we had Leontief, and a good had zero price in equilibrium.
Right.
Then you do not want to attempt to make that good a numerator good. Okay.
And does that change the interpretation of the prices of everything else then as well? Because it's relative. Like how does fixing one price, because like the
Right.
summing them all to one makes sense. It's kind of that.
Right.
I understand that one, but
They're all there. All you can hope, because in general equilibrium one variable is free in the price vector, right? The size of it is free. The length of it, the norm of it. It is inherently arbitrary. You can only talk from general equilibrium about relative prices. Right? The price level is completely something out of this. You need to find a way to introduce money into the model and determine the price level. And I'm sure you'll be hearing a lot about that in your macro classes. Okay? All right, so question one was that. Anybody else? Or Luke asks a second question.
go for it. All right.
Okay.
So on the topic of prices,
Yes.
Walrasian equilibrium. I like so the without prices makes sense. I was just a little confused. I was reading through. I was like skimming through stuff today. Is the introduction of the budget line the I'm a little confused at the introduction of prices into a Walrasian equilibrium.
Okay.
And just exactly like it becomes the budget line that ends up being the hyperplane, right?
Yes,
that
yes,
would separate
yes.
the convex sets.
You don't need quotes, by the way. It is a
Okay.
hyperplane.
Well, then yes, the hyperplane.
Yes.
And so is that just taking the model of the standard exchange and then saying, okay, well, let's add a budget and let's just throw prices in.
Okay.
Is that
Let me attempt to phrase this in such a way that I think you are trying to figure out why did I spend all this time in my lecture notes talking about we can do everything about Pareto efficiency without introducing institutions and prices, and then suddenly I put them in.
yes.
Okay.
Yes,
all right.
thank you.
Okay. All right. Okay. So, first of all, let's just step back. Is it clear that discovering what allocations are Pareto efficient can be done without prices? Right? There is no need, because what you have is a bunch of optimization problems, alternative ones you can use, right?
Mhm.
Either take one person, keep them as the constraint, or if you have multiple people, take all but one, set them at a particular utility level, and maximize the last one utility given those constraints. Or take a weighted sum of utility functions and maximize them subject to the feasibility constraint, right? And then in all of those cases, you have a mathematical problem that involves the following information. What is feasible? And what are the preferences and therefore the utility functions of everybody? Nobody has said a single thing about prices, right? But we know how to solve maximization problems. So there you go. You can find Pareto efficient allocations. Now you say, well, great. What is the amount of information that we need here? A lot of information, right? In fact, back in the early 1940s, there was this big debate with Marxist economists of the time, mathematical economists, saying, look, this whole thing is an elaborate maximization problem. You can build a centralized bureaucracy to solve it. It's the Lange versus, I forget the other, Lange-Lerner controversy or debate, something like that. Oscar Lange, he was definitely one of the people who, Polish, I think, who were participating in that debate. Mathematically, that just hammers home the point that Pareto efficiency is a bunch of maximization problems. That's it. All right? Now, then people like Hayek come along and say, and where are you going to get the information that you need to set up the problem and solve it? Never mind that it is extremely difficult, even if you knew everybody's utility and every firm's technology. Suppose you somehow magically know all of this. How are you actually going to solve the problem? A problem with millions of objective functions and or constraints and millions of variables. Even, right? But you don't know that information. How are you going to find out what people's preferences are? You're going to ask them, they're going to mislead you because they know you're going to use it in a particular way. Same with the firm. So you're going to tell them how much does it cost to produce this. They're going to tell you it costs much more, so they will be allowed to overprice. Right? Okay. So then you have to ask, okay, you can centralize this. Yes, it's a beautiful mathematical problem, but is there a practical method to achieve the same result? Right? And ever since Adam Smith and the Wealth of Nations, you have the story that if you have competitive markets, they will achieve it. If you have competitive markets with all the assumptions that we threw in, right? But competitive markets work with prices. So now we introduce markets and prices, competitive markets and prices, and now it's called the Walrasian equilibrium, right? Because Walras himself set it up as excess demand equals zero in all of these markets. So he essentially formulated that view of the problem for the first time. All right? So now we introduce the prices as a practical way of achieving Pareto efficient allocations. Okay. And once you realize that we put some very strong assumptions on the model, then you study you use the rest of your career in economics to relax some assumptions and do something hopefully more realistic. Okay. Does that answer the question? Prices as tools.
I think so.
Okay?
Yeah.
And then, of course, from math, we know that the Lagrange multipliers already serve as shadow prices.
Right.
People like that were talking about that. And they said, well, find the Lagrange multipliers and use them as prices. But then, as I argued, the informational demands for doing that are ridiculously high, and it's impossible.
Yeah. Okay. I think that makes sense.
Okay? Right.
Yeah. Okay.
All right. Next question.
The only other one I had was, it was about looking at the comb triangles
Yes.
with when you relax the endowment. So you assume you let the consumer have an initial endowment of a public good.
Yes.
But I
Oh.
think there's a section. I
Yes,
was
yes.
skimming through and I did see a section that did cover part of that.
That actually is very simple. If you cannot diminish the amount of the public good, which is I think how Williams covers it, right? And if we have origin 1 and origin 2, right? And notice how you extend the axis to realize that for person 1's point of view, we're looking at all of this. From person 2's point of view, we're looking at all of this. And each individual does not need to know where the triangle ends, because that would mean knowing things about the other person. And why would they know these things? Same with the Edgeworth books, right? Okay, so if the endowment is down here, it means the endowment of the public good is 0. But you may have an endowment of the public good, this much. Then if the public good cannot be reduced from an endowment, if there's no free disposal, then you do everything, but now everything you do is in this part of the triangle.
Okay.
So you just have a smaller triangle.
Okay.
Notice that it's still equilateral. Everything still works. Okay?
Yeah.
But the main reason I don't, and he doesn't in the article, emphasize this case of a positive endowment of the public good is that it is very difficult to motivate. Perhaps it is the basic level of norms of social interaction that allow us to benefit by talking to each other and not fearing that the next person of your species you see in the jungle is actually going to kill you, rather than be willing to trade something with you. There is a big, fantastic book, which probably we should make all principal students read about that, but I'll mention it. It's called The Kindness of Strangers, or something with strangers in the title. Because incidentally, if you look at chimpanzees, if two different groups of chimpanzees encounter each other in the jungle, most likely the males are going to just fighting and trying to kill each other immediately. Humans are a little more peaceful than that. Otherwise, we would never have created any sort of social and economic system.
Right.
All right?
Yeah.
So, do you want to call that the public good? Sure. But then, actually, it's possible to diminish it, unfortunately. Right? You can get a society as polarized as the US is becoming.
Oh, okay. Yeah.
Or just look at 1861 in the US. And suddenly you have 4 years of civil war.
Okay.
But for other public goods, what does it mean to be endowed for us individually, right? Because this is one individual and this is another. What does it mean to be endowed with streetlights? Okay. In our top typical mixed economy like the US or most European countries and so on, we don't have property rights on streetlights and streets and so on. They are literally owned collectively. So, and then the nail in the coffin of the argument is, since all the action will happen in a triangle anyway, you might as well normalize what you consider 0 to be down here and have a bigger picture to play
give
with.
yourself more space.
Okay? Answer your question?
Yes. Yeah.
Okay. Any other questions? Anything from Thompson's paper? All right.
Adjusted that, yeah.
All right. Anything that particularly troubles you about the general equilibrium homework? As I said, I will post an answer. Okay. So, homework then. We have 23.2 first, correct? I think so. Okay. So that's on page 430. And it says, suppose that U1 and U2 are both homothetic in the xi and the g arguments. Derive the conditions for the Nash equilibrium level of contributions. Talk about the terse statement, but I think you know at least what section of the book it refers to. So if you go to that section on page 4, it starts on page 420, right? And you flip and flip and flip, and near the end of that section, you observe that he has a worked out example for Nash equilibrium, or in the case of Cobb-Douglas. What aspect of the Cobb-Douglas preferences is he using here? Read the first two lines in the equation. He says, consider a previous example with Cobb-Douglas utility functions. Applying the standard formula for Cobb-Douglas demand functions we have. And he has an equation in which he takes the endowment, any endowment, right? And says, look, a constant fraction of that will be devoted to, what's the F here? Is it it's the public good. The person will want a public good, right, to be a fixed fraction of their endowment, right? And of course, what fraction depends on the person, because it depends on the particular exponents of his utility function, right? Now, so that's one thing. Now, in the problem, he doesn't say Cobb-Douglas, but he says something very similar, homothetic. When you have a homothetic utility function and you do your standard utility maximization with a constraint, again, you will have that each good is demanded as a constant fraction of the... So, in other words, once you make that connection, who is stopping you from then referring to the worked out example in the book and said, I could use the same notation and then everything in there applies? Okay? So really what he's after here is for you to recognize that homotheticity matters because for demand problems, because it makes your demand of each good be a fraction, a constant fraction, in value terms. Here the value term is a little obscured because we name the price of the private good 1, right? Am I making sense? It's clear? So in other words, this is very easy once you recognize that feature of homotheticity. 23.4 is the next one, correct? Okay. So that one, we have n agents, but they have identical Cobb-Douglas utility functions. There is a total amount of wealth W, which is divided among k of the agents, not necessarily all of them. K is less than or equal to the total number of agents, n. How much of the public good is provided, and how does the amount of the public good change as k increases? Okay? All right, so how will you approach that? Well, there's two different people here. Those who have income and those who don't. Right? If I'm reading this correctly. The wealth, sorry. Yeah? So for each one of the k people who have wealth, you have Cobb-Douglas do that example again. Right? But with multiple people. So the example works with only 2 people. But, you know, how do you step from having 2 people in the model to having more than 2? You say, well, I'm person 1, I have G1 to choose, and and I take G2 all the way to GK, I can take those as constant, as opposed to only taking G2 as constant because there are only two people. It's totally symmetric, so once you solve it for one I among this group, then you know how much is contributed, right? And if you know that, then you know everything, because the people who have no wealth are not going to contribute anything. You don't have to work to find that conclusion. They'll have to rely on the public good provided by the others with the wealth so that they survive. Okay? So that is 23.4, and then 23.6. Is that it? Or did I assign something else? Let me see. Oh, 23.3. I didn't talk about that, but I assigned it. No, wait a minute. Oh, right. Okay. 23.3 is a kind of an introduction to 23.4. So, identical utilities, Cobb-Douglas, but one person has more wealth than the other. Okay? So in this case, again, who is going to set up the problem? And you will see pretty immediately, I think, that the only one who will contribute, well, set it up, follow this procedure in the chapter. I don't want to say more. Okay? It's Cobb-Douglas. Use the little F function approach. Figure out what are the best responses. And finally, we have the grads. I love the story. All those grads in this South Seas island consume only coconuts. I like coconuts. I think I would be a little tired of them if I were a grad. Good thing I'm not a grad since 1988 when I graduated. So they use the coconuts for two purposes. Either they consume them for food, or they burn them in a public religious sacrifice so they can pass their prelims.
Does this work? Is this,
No, I don't know. I'd rather you give me the coconuts and not burn them, you know. Okay, so the total number of coconuts contributed to the offering is the sum of the individual contributions. So we have a public good again, right? He's just being fancy or funny with his terminology. We have a utility function which is quasi-linear in this case, right? So the linear good is the private good. The marginal the marginal rate of substitution is the AI. It's bigger than 1. So then he breaks it down for you. Part A. In determining his gift, each grad assumes that the gifts of the others will remain constant. That is, of course, the typical Nash equilibrium assumption that you take everybody else's actions as constant, as given. So then you have a maximization problem. You maximize your utility, right? Given the fact that everybody else has already chosen some numbers to contribute that you cannot change. All right. Then part B is what will be the equilibrium amount of the public good. For this one, here's my hint to you. Take all the A sub I numbers, those marginal rates of substitution for the public good, and put them in order. A1 is the highest, and then goes down from there. And think, will the person 1 contribute? Will the others contribute? And how can I get that from the first order conditions?
Would anyone want this coffee? It's free, it's hot, and it's...
Probably yes. Could you leave it there? Sure. Thank you.
Yeah. Sorry to interrupt.
Okay. Who sacrificed coconuts to the god of coffee? All right. That's one of the better ways to interrupt a session. Okay. Although, if they brought some wine, I wouldn't say no either. But that's just me.
Same.
Who will free ride in this problem? If you answer part B, you know the answer to part C, I think. And what's the intuition? What's your guess? Somebody give me a guess. Who contributes and who doesn't? Without doing any math. My hint was rank them. A1 is the highest, A2 is less, and so on. All right, it's a little hard, but you will see. Let me give you another hint. What is the first order condition for an interior solution? That is, for a person to actually contribute a positive amount, right? That's not too hard to find. You set equal, you use the derivatives and all that to the first order condition, right? It will involve obviously the AI of the person, because when you take the derivative, it will be AI divided by G because of the log, yes? Take it from there. You will see, okay, I'll have one more hint. There's going to be only one person for whom this condition can hold. Everybody else is hitting the boundary and contributes 0. Okay? So here I actually talked myself into telling you most of the answer. See, I'm such a nice guy. All right. Part D. Part D has now is completely separate from finding the solution to the game, right? It's what's Pareto efficient. You know the condition for Pareto efficiency, apply it, right? Sum of the marginal rates of substitution equal to the marginal cost, blah, 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 yeah? So here, by the way, I can now connect your question about the prices in Wahlerian equilibrium with this, which might be enlightening. In this model, in this particular problem, we have part D is the logically prior question, which should have been part A, actually, in my opinion, to find what is Pareto efficient. Then you set up a particular mechanism to achieve it, or to ask, does this mechanism achieve it or not? In the Wahlerian equilibrium case, the mechanism was competitive markets. Here, the mechanism is this game of provision of the public, good. Not the same story, but it's an actual mechanism. One worked with prices. This works by solving a game by finding its Nash equilibrium. Okay? And that's it, I think. That was it in terms of homework. Now, is everybody sure you have no questions for me about William Thompson's sections? Is that because you didn't have a chance to read it, or is it, okay.
Tonight.
All right,
Tonight.
fine. Okay, no, understood. Okay, so the other thing is I put an announcement on Canvas about extended office hours. So please utilize them, use them. If you can in advance, tell me when you're coming, let me know. It makes things easier, because I have also my undergrad class and I don't want to have lines of people waiting. And I have not added an office hour on the Tuesday, the 19th. If people ask me, I'll probably be around earlier than the exam. But I don't believe that it's a very good thing to encourage people to ask questions just an hour or two before an exam. That's a little too late. So I try not to encourage it. Okay? So use the other office hours, shoot me emails with questions, whatever.